Good day, students. I hope I find you well. In my previous video, I did another question on titration. Today, I'm going to do another question on titration. In this case, we're going to be using potassium hydroxide and sulfuric acid. I hope you still remember the steps that I showed you in my previous video. In this titration, 25 cubic centimeters of 0.08 moles per dm cube potassium hydroxide is neutralized by 20 of H2SO4. Then we have an equation there. From my previous video, I hope you still remember what is a standard solution. I'll remind you, a standard solution is a solution in a titration whose exact concentration is known. So whenever you're dealing or you're handling such calculations, start with the standard solution. Okay, so obviously what we're going to do first is to calculate the number of moles of the base. Why? Because it's our standard solution. We know its volume and we know its exact concentration. So what are we going to do? We're going to calculate number of moles of the base, okay, of potassium hydroxide. Okay, number of moles, the equation for calculating number of moles is concentration times volume. Concentration we are given as 0.08, and then our volume is 25. And as I mentioned last time, we have to say 25 over 1,000 so that we get our answer as moles per dm cubed. Okay, so if we do that, 25 times 0.08, we're going to get our answer as 2 times 10 to the power minus 3 moles. Okay, these are the moles of the base. Second step is now to look at the relationship. What we have, okay, we have our base, okay, and we have our acid. I go to my equation, okay, base and the acid. My relationship is 2:1, okay. I calculated number of moles of the base here, so it's 2 times 10 to the power minus 3. I want to calculate the number of moles for the acid. As I mentioned last time, just do your cross multiplication, okay. This one will multiply by that, and this one will be like that, okay. Meaning to say your 2x is equivalent to 2 times 10 to the power minus 3. 2x is equivalent to 2 times 10 to the power minus 3. Therefore, my x, if I divide both sides by 2, I'm going to get an answer 1 times 10 to the power minus 3 moles. Okay? And it actually confirms the relationship in our stoichiometry there. Okay? If you check 2 times 10 to the power minus 3 as to 1 times 10 to the power minus 3, if you simplify that ratio, you're going to get 2:1, which is indicated there. Now we have number of moles of the acid. Our next stage now is to go on and calculate the concentration of the acid. Okay, that's the last stage of this question. Number of moles we have calculated, and we actually saw that is 1 times 10 to the power minus 3. So concentration, our concentration is number of moles over volume. So our concentration is number of moles over volume. Okay, number of moles 1 times 10 to the power minus 3. And then what is our volume? If you go to the question and you read carefully, our volume is 20. Okay, remember you have to say 20 over 1,000. If you simplify that using your calculator, you are going to get 5 times 10 to the power minus 2 moles per dm cube. Okay, once again, very simple calculations. When you are doing your titration, you're going to have a standard solution whose exact concentration is known. Start with that. Find the number of moles. Use the equation that you are given to migrate from the standard solution to the unknown. After that, you have number of moles of the unknown. Then, if you are given the volume, you can use this equation. Concentration is number of moles over volume. And when you do that, you can now have the concentration of the sulfuric acid. That's how we handle titration. Even when you go to A level, the steps are similar. It can be acid-base titration. It can be redox titration. The steps are essentially the same. One of the solution, you're going to know its exact concentration, and we call that a standard solution. Thank you. That's what I had for you today. Thank you.